So yesterday we took some time to do two different types of factoring. So one was what we call like factoring an easy trinomial. This happens when a equals 1. And we have the type of factoring when a is not equal to 1 and cannot be common factored out to make the coefficient of x squared equal to 1. So I'm going to ask you guys quickly here just to do like a little assessment of the quadratics that are here. Which ones would have to be common factored? And which ones would have to be factored with easy trinomial factoring or can be common factored to give us easy trinomial factoring? And which of them have to be factored using hard trinomial factoring, the one where we split the center term apart and do grouping? So I'll give you a second to decide on that. Okay, if you have your own piece of paper, you can just jot it down. All right, so can I get someone who can tell me the first couple? Maybe give me 1 to 3. What type of factoring do we use for each of those? Lila.
So the first one would be easy.
Yep.
And then the second one would be hard.
Yep.
And the third one would be hard as well.
Okay, who can do the last 3 for us? Nicole, go ahead.
The fourth one would be easy.
Yep.
The fifth one would be easy as well. But the last one would be hard. Okay,
perfect. So the couple that we labeled as easy that actually don't have coefficients of 1, so this one and this one, they actually can be common factored to give us that type of easy factoring. So once we common factor the 3 out, then inside the bracket, the coefficient of x squared is equal to 1. So always be looking out for those. Make sure we always common factor first. Same deal with this guy. This can also be common factored out. So these are the things that we want to look out for. Okay. So that's our first part. So just to sort of recap here, we have simple factoring or easy factoring versus long factoring or hard factoring. So this will be easy, hard, and easy factoring happens when a equals 1. So we would have y equals ax squared plus bx plus c. And simple factoring or easy factoring is going to happen when a is equal to 1 or can be common factored out. Now, even if your full a value can't be common factored out, you still want to common factor first because it will still actually make the process of doing that long factoring or hard factoring a little bit easier, just because you'd be working with smaller numbers. Okay, so long factoring happens when we're in the same form, of course, but this is when a is not equal to 1 or cannot be common factored out to give us a coefficient of 1 in front of x squared. Okay, so in all cases, we always want to common factor first, always. Just going to turn my video off here. Because that can sort of make our life easier in both scenarios. So common factor first, always. We talked yesterday about if you don't common factor first, what might end up happening is that you end up with a bracket that at the end that has a common factor that you'll have to common factor anyways. So if you don't do it first, it will be more difficult to factor and you'll have to do it at the end anyways. So always remember common factor first. Okay, so I just want to go over a couple more examples today. This is going to be a mix of easy factoring and hard factoring. So you will have to decide on the appropriate strategy to use on each question to get it factored. Okay, so first one here, we need to decide, well, first we want to always common factor first. So in this case, I don't really have a common factor that can be taken out of every single term. So if I've checked for that, then we'll decide on the type of factoring here. So who can tell us what type of factoring we'll want to use to factor this quadratic? Excuse me. You can use the raise hand feature. What type of factoring? Brad?
Would it be easy?
It would be easy. Yep. So when we do easy factoring, we are going to figure out what is the product that I need. And I'll write all the things that multiply to that product. And we'll figure out what is the sum we need. And then we'll decide on our numbers based on what fits both of those things, what two numbers fit both of those things. So just as a reminder from yesterday, can somebody tell us in this situation, what is the product that we're looking for and what is the sum that we're looking for our two numbers? Nicole?
Is the product -6 and the sum -1?
That's right. Okay, so we want our product to be equal to the C value. Our sum will be equal to the B value. Now, since this is easy factoring and there's a coefficient of 1 in front of x squared, as soon as we find the numbers, we get to put them in the brackets. So I'm just going to start writing out all the different things that multiply to -6. So we have 1 times -6, -1 times +6. We have 2 times -3. And we also have -2 times +3. Those are all the different combinations, paying attention to the fact that we want this to multiply to a negative. So we need to have a combination of a negative and a positive. Now, if we check the sum of each of these, I want the sum to end up equaling -1. So this one doesn't work. This one doesn't work. This one looks like it works. That one's -1. And then this one would be, of course, +1. So here are our numbers. If you want, you can even indicate that at the bottom of your chart. Maybe we can do final numbers. Okay, so this is our scenario that fits both of those criteria. Multiplies to -6, adds to -1. Can somebody tell me what this is going to look like now that I have my numbers and put them into the brackets?
I could do that.
Go for it, Nora.
So x squared plus 2x, then -3x, then -6.
Okay, so
Quick question.
yep.
One of the questions I realized I got wrong because I mixed up the order. Like let's say I put the 2 last and I put the 3 before. Does that actually affect? Because I think I put it in the right order, but I don't know why it affected it.
It should give you the same answer no matter which order you choose. So I'm going to go to the worksheet after this and then you can ask if you want, but yeah, it should not matter the order that you put these in.
Okay.
Okay, so I'm going to ask you guys, is this necessary for me to split this -x up into these two numbers if I have a 1 in front of my x squared here? What do you guys think? Sophia?
Yes.
Yes?
Yeah.
This is easy factoring though, right? How do we do easy factoring? Once I find the two numbers, I should have my brackets right away. Somebody tell me what those numbers would be. Or sorry, what those brackets would be. Charlotte?
Would it be x plus 2 and x minus 3?
Yeah, so I actually don't have to do this whole process if it's easy factoring. So if it's easy factoring and the coefficient of x squared is equal to 1, as soon as I find my numbers, I should be able to factor this. So at that point, I'm done. I don't have to do the whole split the middle term into 2 options and do it by grouping. Will it still work if you do that? Yes, it will still work, but I'm doing a whole lot more work than I need to do. So yeah, if we have an easy factoring question, as soon as we find the numbers, you put those into the brackets with the x's. Okay, that's probably like one of the most classic mistakes that I see is people will do the hard or long factoring method when they don't need to. Okay, so that's our easy factoring. Find your numbers, put them in the brackets, you're done. Let's go to, let's try this. Actually, we'll do this one. All right, so first things first, we're always going to check for a common factor. So 6, 11, and 4. Are there any common factors here? I think not. So common factoring, not possible. Can somebody tell me, is this the easy factoring method or is this the factoring by grouping method that we need to split the middle term? Is this easy or hard? Lila?
It's hard.
Okay, that's because the coefficient of x squared is 6 and we couldn't common factor that out. So this is hard factoring, which means we'll have to do grouping. Okay, but we are still going to create our usual chart to find our numbers here. So I want to figure out the product and the sum. Now this one's a little bit different in finding our product. Can somebody tell us when we have a coefficient that's not equal to 1, how do we get our product? And what would that be for this situation? Lila?
Like you do a times c, so 6 times 4.
Yep. So in this case, we want to do a times c to get our product. So that will be 24. And our sum, of course, is still that middle b value, which will be 11. So we need to find all of the different products of 24. So I have 1 times 24.
Is the b always the sum?
Yes.
Okay, and then for hard factoring, you do a times c, and then easy is just the a and the c still. Or
I
just
mean,
c.
Yeah, but if it's a times c, even with easy factoring, it will be 1 times the c value, right? Because when I do easy factoring, like if we look at this example,
Yeah.
if I'm doing easy factoring, even if I do a times c, I'm still getting -6, right? Because the coefficient is 1.
Okay.
Yeah, so same kind of idea. But yeah, you only really have to look at the c value for easy factoring. Okay, so lots of different combos for 24. And like I said yesterday, I don't need you guys to write every single one of these. If you start to get confident with finding the numbers before you write all of this stuff, I'm totally fine with that. So which of these has a sum of 11? Are there any options that you see that will add to 11?
8 and 3.
8 and 3 works, yes. So 3 plus 8 equals 11. So this must be our group of numbers. Okay, so our numbers are 3 and 8. Now, this is the scenario where we can't simply just put them into brackets. We have to split that middle term up into 3x and 8x. Okay, so find your 2 values, split it up. And I'm going to encourage you guys, if you're unsure of the whole thing that Nora just asked me, where she said, oh, does it matter if I put 3x first or 8x first? Do the opposite version that I do and see if you get the same answer. I guarantee that you will if you do it correctly. So I'm going to split 11x up into 3x and 8x. You can do 8x and 3x if you want. But if you add these back, you will notice that you get 11x back. That's the whole idea. We're not changing the equation. We're just splitting the equation up so that we can work with it to get it factored. Okay, so we're going to do our groups. This will be group 1. This will be group 2. We're going to common factor from each group. So what's our common factor for the first group and what would be left in the bracket? Brad.
3. Oh.
3. There's something else that's common. Other
3x.
than
3x.
3x. Perfect. Okay, and Brad, what would we have left in the bracket?
3 plus, I think it's just 3, right? No? 3 plus
So
1?
6 divided by 3 is?
3x plus 1. Or 2x plus 1, my bad.
Okay, there we go. You got it. Good, thanks. Okay, and the second one, common factor, and tell me what's left in the bracket. Brad, I think you're still unmuted if you want to just mute yourself. Lila, do you want to do this one?
Sure. So the common factor would be 4.
Yep. And always with this, we want to take out the number with its sign. So I'm going to do +4. And what would be left?
Left in the brackets would be 2x plus 1.
Perfect. And I know that I've done this correctly if my brackets are the same. That's the whole point of doing this factoring method. If I don't get 2 brackets that are the same, maybe I've found the wrong numbers. Maybe I haven't common factored fully. I will have to look at that. So I need to get the same brackets in order for this to work. Because the next thing that I'm going to do is I'm going to take out the common bracket. So we're going to take that out and we will be left with 3x plus 4 in the second bracket once we've removed the common bracket. And that will be our factoring by grouping. Okay, any questions so far?
It's so easy to do it with the class, but when you're alone, it's kind of not bad.
Yeah, remember I said that yesterday. It feels like when we do it together, like you can sort of do it, but it's different when you practice on your own.
Yeah, you were right.
Yeah. Okay, so on that note then, let's hop over to the worksheet from yesterday, and I want to take up questions that you guys had, or at least get you started on some of those questions that you had any trouble with. So I'm going to hop over to the chapter 5 workbook and give me your questions. What do you guys want to take a look at? Feel free to type them in the chat as well. I know people have questions, so don't be afraid. Okay, ABC on what, Cam? Number 1 or 2?
Oh, sorry, I just realized I was unmuted. Yeah, it's number 1.
Number 1, okay. 2J. Okay, feel free to continue typing in the chat. I will start with 1AB. I didn't assign C, but I'm happy to do C as well from number 1. Okay, number 1A and 2G, I see. Okay, number 1A. So I am looking for what product and what sum. Who can help us with the product and sum?
Product 3, sum 7.
Nope, not quite.
The product is 6.
Yeah, you got to do A times C. So product is 6,
And the
sum
sum
would
is
be
7.
7. Great, thank you. Okay, so watch out for that. This is when A is not equal to 1. Also, one thing that you would want to check before you do that part is, can you common factor? And in this case, we can't. So we can go ahead and figure out the product and sum, and I will figure out all the things that multiply to positive 6. There's 4 options. Now, do any of these have a sum of 7? Okay, I think I'm seeing 1 and 6. If I add those, would have a sum of 7. So those work as our numbers. So you're going to take the 3x, or sorry, the 7x, and split into 1x and 6x. Now, again, does not matter the order that you put these in. Suppose maybe we put 6x first and 1x second. That would work, okay? So the 7x becomes 6x and x. And then I'm doing my groups. So I'm going to common factor 2x from the first group. And I will be left with x plus 3. And then from the second group, what do I common factor when I just have an x and a 3? This is sort of like, we usually don't common factor anything when there's not anything common. But when we factor by grouping like this, we actually have to factor something from here.
Is it 1?
It is 1. So we will take out a positive 1. Okay, that might have been a source of some confusion. If you, in some certain scenarios, if you didn't have a common factor, we will always take out a plus 1 from that second set of terms. So all we're going to be left with is x plus 3, which means that our final answer here is x plus 3. And then I'll be left in the second bracket with 2x plus 1. Okay, can someone take us through part B here? Who got 1B? Melody, go ahead. Oh, did we just do this one in our lesson, actually? I think we just did this one. Yeah, we actually just did this one. So this one I'm not going to do because we did this one together already. So let's skip over that. Cam, is that okay?
Yeah,
Since we already did that? Okay. And you wanted C as well, right, Cam?
Yes, please.
Okay. Melody, did you happen to do C or no?
I didn't.
Okay. Wait, is this? Oh, this one is actually very similar to number 1. So your product is going to be 3 times 2, which is 6, and your sum is going to be 7. So this one actually will end up being the same numbers as number 1. It's 1 times 6, and 1 plus 6 will give us the product and sum that we need. So those are our numbers. The only difference between this one and number 1 is that number 1 had 2x squared and 3 here, and this has the opposite. So when you put in your numbers, again, either order is fine. So let's say maybe we'll put in x and 6x, and then do your groups. So there's group 1, there's group 2. What is the common factor from group 1 here? This is 3x squared plus x. Cam, this is your question. What do you think? What's common between these two terms?
Common between the first one is 1, and then the other one, I'm pretty sure, is 2.
So this one has a common x in each term.
Oh, you can do it by just x.
Yep. Be like 1x, right? So I'm going to take out an x. That means I'll divide each term by x, and then I'll have 3x plus 1. And you're right, the second one will be positive 2, taking out the number with its sign. And then you can divide each of these by 2. So we'll have 3x plus 1. There we go. We have the same bracket. That's good. Good sign. So it'll be 3x plus 1, and then the second bracket, x plus 2. that good, Cam?
Very much, thank you.
Okay, no problem. Okay, so I have a questions from 2B and C, so let's take a look at those. Who can take us through 2B?
Can I see the answer for C again real quick?
Yep,
Yeah, okay, thanks.
yep. Okay, Melody, go ahead.
So you start by doing the product and sum table like always. So for the product, you would multiply the A and the C. So that's
Okay.
56 times -2, and that would give you -112.
Yep,
And then for the sum, you just take the B value, so that would be -9.
awesome.
And then like this part took me a really long time. So I actually had a question about this. Do you just have to keep trying every single one? Like every factor you can think of? Because it takes like a really long time.
Yeah, so when the number's bigger, of course, there's going to be like a few more factors in there. I usually like, if I check the ones, for instance, like 1 times 112, or like any combination of 1 and 112, like I know that's not going to add up to -9. So it has to be two numbers that are like at least somewhat close to one another, within like 9 of one another. Like even like 10 and, or I guess 10 and 12 doesn't multiply, but even like if I divide this by 2, for instance, like 66 and 2, that's of course not going to add up to -9. So it's got to be, I know at least that it's got to be two numbers that are a bit closer together. So I would start maybe like in the teens and try to find something there.
That makes sense. Well, there was a bunch of them, but the one I got is -16 times 7.
Okay. So, I mean, other combinations, again, like I said, could have been like 1 times -112, 2 times -66, like all of these types of things. Or actually, no, sorry, it would be 56. But if we notice these numbers are very far apart, these are not going to add up to -9. So I would start going into the numbers that are closer together, into some of the teens or like the high numbers before 10. So yeah, Melody ended up finding -16 and 7 as the numbers. Perfect. And take us from there, Melody.
Then you would just say y equals 56x squared, and then you have to like split up the b value, the -9, into the factors that we just found. So you would
Okay.
say -16x plus 7x, and then you just write -2 for the c.
Great. So go ahead, take us from there.
Then you do the grouping. So it would be 56x squared minus 16x for one group, and then 7x minus 2 for the next. So you would find common factors for each one. So for 56x squared minus 16, I found you could take out the 8x.
Great.
And then you would have 7x minus 2 in brackets.
Mm-hmm.
And then for the next group, you could take out just a 1. So it would be +1.
Yep.
And then 7x minus 2 in brackets.
Great. And the fact that we have two brackets that are the same tells us that we must have done that correctly. So that's good.
Then you have to divide out the 7x minus 2 in each bracket.
Mm-hmm.
And then the other bracket, you just write what's left, which is 8x plus 1.
Awesome. So that would be our final answer. Yes, it's true. If your numbers are a little bit higher, like we've been working with like some lower numbers, if your numbers are higher, it might take you a little bit longer to find the factor, and that's okay. You just do it systematically, start writing things out until you find your sum. Okay, and 2C, can someone take us through 2C? No one was able to get 2C? Other than Melody, because she already took us through one. Nora, did you want to do it?
Here's the thing, I did it, but it was last night, so I don't know if I remember it, but I could try.
Okay.
So we have to do 9, so A times C, so 9 times 1, just 9.
Mhm.
And then it has to add up to the sum of 6.
Good.
So I did, what did I do?
So
So I
here's
did
all the
3 times-
options.
Yeah, so 1
There's
times
not too
9, yeah,
many.
3 times 3. And then it has to add up to 6, so I chose 3 times 3 because that adds up to 6.
Perfect.
And then you write it as equals 9x squared plus 3x again plus 1.
Great.
And then you group it and put into brackets, so 9x squared plus 3x, then plus 3x squared plus 1.
Okay.
And then you have to divide it, so then I did 9x.
I don't think this has a 9 in it.
Wait. Yeah, I did, because 9 divided by 9 would be 1. And 9
Right,
divided
but
by
3 divided by 9 is 1/3. So we need to figure out the biggest thing that we can divide out of both of those. X is part of it. But what's the most I can divide out of 9 and 3? The highest number.
3.
Yeah. So it'd be 3x. And then we'd be left with 3x plus 1. And then what did you take out of the second one, Nora?
I did 3x.
Out of the second one?
Yeah.
But this
That was
doesn't have a
just 3.
3x.
I just did just 3 because
This doesn't have a 3 though.
3 divided by 1. Wait.
No, it'd be 1 divided by 3. That'd give you a third.
Oh, yeah. So
So the most you can take out from this is just 1.
1.
Because they don't really have anything common.
Yeah.
But take out a plus 1. And we'd be left with really like the same thing, 3x plus 1. And then final bracket here, 3x plus 1. And in the second bracket, we'll be left with 3x plus 1. Can somebody tell me how I express this a little bit more simple when I have, or a little bit simpler, I should say, when I have two of the same? Lila?
You do 3x plus 1 in the brackets and then squared.
Perfect. So that should be your final answer for this one. Okay, so remember guys, when you're doing this factoring by grouping, you need to come up with the greatest common factor that divides evenly into both of those terms in each group. So I can't divide, for instance, 3 by 9 because that's going to give us a fraction. So I want to think about what's the biggest thing I can divide into both 9 and 3. So the highest thing that I can divide into both of those is 3. Okay, let's do the last two. 2J and 2G on the next page. I'll start with 2G. All right, so I'm just going to take you guys through this. So can we common factor anything out of 6, 29, and 35? I think the answer to that would be a no. So we will move on to finding the product and sum. Sorry, I'm just grabbing my calculator here. So our product is going to be A times C, which is 6 times 35. And that's going to give us 210. So positive 210. Sum is the B value, which is negative 29. Okay, so here's a little tip for you guys. If your sum is negative, but your product is positive, I know that my two numbers have to be negative numbers. I can't have two positive numbers that are going to add to negative 29. So I must be finding combinations of two sets of negative numbers that will multiply to a positive, but add to my negative. So I actually don't even really need to explore all the positive options of this. I'm going to explore all the two negative number combinations. So like for instance, -1 times -210. Of course, that does not add to negative 29. And then I would literally just go along. If you're not sure what the numbers are, just go along and start dividing 210 by each number and see if it goes evenly. So I just divided 210 by 2 and it goes in evenly. This still isn't getting me to negative 29. So 210 divided by 3, and that actually goes in evenly. So it would be -3 times -70. Still not getting me to negative 29. Let's try 210 divided by 4. That doesn't go in evenly. 210 divided by 5. So that goes in evenly. Still not getting me quite to negative 29, but we're getting close. If you try 210 divided by 6, this goes in evenly. So 210 is 6 times 35. You have to do A times C for this type of factoring.
Wait, how do you know for the right column? Like, how do you know how much you're supposed to go down by? Or are you just guessing?
I'm just testing. I don't know how much I'm supposed to go down by, but I'm just testing all the numbers that divide evenly into 210. Okay, so I'm still not quite there yet. I have -7 times -30. Still not getting negative 29 for my sums here. So it must be a bit of a bigger number here. 8 doesn't go in, 9 doesn't go in. 10, of course, goes in, -10, -21. Still not adding to negative 29, which is okay. 11 does not go into 210. 12 does not go in. 13 is definitely not going to go in. Check 14. 14 goes in. -14 times -15. Once I get to this, where I have two numbers that are so close together like this, if I start testing again, going on the upward end of this, I'm going to end up just testing. Basically, nothing else goes into 210 other than like this, because I just got two numbers that are directly next to one another. So I know that there's really not many more things. And I've already accounted for a bunch of the upper numbers in this set right here. So I found my numbers. It just so happened to be my last test, which is okay. But literally, this is what you guys are going to do. I didn't know what the numbers were to start with here. I promise you, I didn't know. I went through and I divided all of these numbers, including the numbers in between, by 210 to see what went in evenly. Okay, so it takes time, but I believe in you guys. We can do it. So here's our numbers. We're going to split 29 into those two numbers. So -14s, -15s. And we're going to do our grouping. So here's group 1. Here's group 2. In group 1, I can take out a 2s. It's the max I can take out from each thing. I'll be left with 3s minus 7. And then out of 15 and 35, if this is negative, I'm going to take out a negative always. So if I look at this set and I see that the first term's negative, I'm going to take out a negative. So it'll be -5, and I'll divide that into each term. So I'll end up with 3s minus 7. And then common factor your common bracket. So 3s minus 7. And in the second bracket, we'll have 2s minus 5. Keep going over the top. Here we go. Okay, so that's another one of those scenarios where we have like a big number here. So we'll just have to take our time to write out all the different products. Okay, last one, 2J. I'm going to create my chart over here. Product will be A times C, so 13 times 20, give us 260, and sum is negative 57. Okay, so I know it's not really going to be any of these sort of like really low numbers, like 1 and 260 is not going to work. 2 and 130, of course, that's not going to work. You can write them anyways. I still know, again, with this one, because this is positive and this is negative, it must be a combination of the product of two negative numbers to add up to a negative number here. So I know that. So what you can do is, again, you can go through all the different numbers that multiply to 260. I think we'll find the number a lot quicker in this one because it's a pretty big number over here. So I think we're going to find it within like the first few. We've got -4 and -65. That doesn't add to 57, but I think we're really close here. And then we've got -5 and -52. That actually adds to -57. So those are our numbers. And actually, guys, when you find your numbers, you can just stop. You don't need to write every single thing out. Just stop when you find your numbers. Okay, so we're gonna split -57 up into -52 and -5. Again, you can choose whatever order here, but I think maybe -52 will fit better with 13 and -5 will fit better with 20. So you can be strategic about the order that you put your stuff in, but again, it should work either way. So the reason why I put -52 with 13 is that -52 is actually divisible by 13. So I can actually take out a 13x from this first set. I'll be left with x minus 4. And then in the second set, because my first term is negative, I will remove a -5. And I'll be left with x minus 4. And again, I know I've done it right if these two brackets are the same. If they're not, you got to go back, check your numbers, and check your common factoring. So what's left? We'll have x minus 4, 13x minus 5. Okay, any questions on that one or on G? Okay, so I'm going to encourage you guys, if you have time today, let's, or even like maybe just do some practice before your assignment. If you weren't getting these ones, there's lots of other factoring questions. I can also post up for you guys other worksheets and stuff like that. But there's lots of extra questions on these ones as well that you guys can practice with. Do you guys want to take your 15 now and then we'll come back and do the actual lesson for today, or do you guys just want to do the lesson and then take your break after? What would you rather?